Let me start with a question here. So actually for the audience, so what's on this picture here? This one is simple, so you can just shout, okay. Yeah, it's engine, it's internal combustion engine, right? So although it looks very complex, and I don't think anybody of us actually can assemble it on our own, right? We heard a lot about it, and we actually can recognize it. It's internal combustion engine. The engines actually, the type of the engine that started technical revolutions, and this has changed the world since, right? What is this? Yeah, it's a core of the nuclear reactor, right? You see these rods with which they control the speed of the reactions, right? That also is taught in schools, right? So we all see these images, and they're we are kind of familiar. Although, sincerely, right, we don't know much about this, right? But we have some concepts with which we can somehow understand what's happening there. What is this? That's a harder one, but not as hard, right? So I hear some rumors. Yeah, it's actually not a DNA, it's RNA. So DNA will be double-stranded, and this is a single strand. And it's, so we all know much about this, not only because of school, right, but because we've been bombarded with this kind of information for 2 years, right? This is actually sort of like a model of messenger RNA, so in this virus age, this is a familiar, this could be a familiar image, right? Okay, what is this? It's a code, okay, but what does it do? That's a hard one. I mean, I'm pretty sure that some of you know for this, right? Maybe a little help, right? So I can actually represent this code with, actually this code does something, right? And I can represent it maybe with these graphics here, okay, or maybe with this simple image here, right? Actually the answer is already here on the screen. It's a logistic regression. It's actually a basic unit. It's actually one of the simplest machine learning algorithms, and it's also one of the basic units we have in deep networks. In fact, deep networks are populated with this kind of computational units. And while I'll claim, right, so we have a schooling system that has, at least in Slovenia, if you go to primary or secondary school, you have a lot of different subjects like biology, chemistry, physics, math, technical education. And I don't know why I didn't put the others. I mean, probably because of space, right? We have history and languages and so on. And the fact is that if we take internal combustion engine, we learn a lot about these engines, right? And that's already in the primary school. In the primary school, kids already learn about the difference between the 2-stroke and the 4-stroke cycle. I mean, this is indeed so, and the difference between the diesel and the gas and the benzene engine, right? So that's, I think, at the end of the primary school, you have several lessons like that, and kids have to actually maybe even draw the engines, right? Maybe draw the model of the engine, right? And later on, they learn about the gas law, the diesel fuel, the gears, right? You have a lot of things in school that actually prepares you to understand internal combustion engine. This is very important because our world runs on these kind of engines, right? We use them daily, and this is very important, right? Also, I don't know, I take biotechnology, which is like, it's proclaimed to be a technology, one of the technologies that are going to drive 21st century, right? And we have that in schools as well. So we learn about these concepts. We learn about the cells, DNA and RNA already in the primary school. I'm not talking about the universities, right? So some universities are really like they go deeply into molecular biology and so on, but like take primary and secondary school, right? We learn about proteins, metabolism, inheritance, and evolution. Of course, now we also learn about viruses and how they spread and how we try to prevent them, right? So we hear about these different types of measures that we can take against them, right? So there's a lot in the education already about biotechnology. And what about the AI? Or like, I don't know, simplified, logistic regression, right? How much do we learn about that in school, in primary school, secondary school? 0. Zilch. Nothing. Maybe I'm exaggerating, right? Of course, you learn something about math and statistics, which is all kind of sort of like a basis of AI, but how many concepts of AI do we have in schools? And here I shouldn't generalize too much because there are definitely some schools that try to introduce this concept, but I actually went through the programs, so through the current programs that the schools use in, that meaning the primary and the secondary schools, so the elementary and the high schools, right? There's nothing really about the AI. 0. So we learn about all the other technologies that surround us, right? But we learn nothing about the AI. Here, okay, so just to start my talk now, here are the assumptions, right? I will assume, and I will not actually promote this because you already convinced this in this. Artificial intelligence is defining technology of the 21st century. Just like microprocessors in the 20th century, it will affect all scopes of life. And at present, except of a few enlightened ones, meaning that people that study AI at universities or by themselves using the MOOCs, or AI is the mystery to most of us, right? You go out in Ljubljana, you stop people on the streets, you ask them what AI is. I don't think anybody will give you a really concise answer. And if you ask them what are the units of neural networks, they wouldn't know. And if you ask them how the machines learn, what is machine learning, they would be completely blank. Okay, so these are the assumptions, right? And my claim here is that this is not okay, right? If there's a defining technology that actually, I mean, that changes the life, that changes this century, right? That actually affects everything that we do. Maybe not everything, but most of the things, right? We should know something about that technology. We should know about the technology that should change the world. One thing, of course, I mean, looking maybe into business more than everything else, right? We should recognize the opportunities that these technologies offers. Right, so in Europe, of course, we would like our society to flourish. Of course, if there's a technology that we can benefit from, people should know about it. People should actually recognize what they can do with this technology and how to use it effectively. But of course, there are also dangers of AI. I mean, I'm an AI researcher. I do machine learning for, I don't know, for over 25 years. This technology is also very dangerous, and it can not only affect all the ways of life, right? It can also affect our the ways. I mean, that it has profound economical and political effects. It affects our democracy as well. So I would not like to go in this direction. I'd just like to say that if this is the case, and I strongly believe that this is the case, right? That the technology that is so pervasive, right, can be so much, I mean, can be dangerous as well, right? People actually, I mean, everybody should have the knowledge about the concepts of the AI, not only to their benefit, but also to think how to use it ethically and how to actually steer the world towards democracy and society that should be ethical and okay. Okay, here I actually finish with my introduction, right? So I claim that AI is actually not taught in schools currently. I mean, of course, with few notable exceptions, but on general, right, we don't have an AI in schools. There's nothing in primary school. There's nothing in secondary school. There's, of course, a lot of different faculties and departments at universities, right? Probably not in every department, right? But if we take primary and secondary education, there's nothing. And there's also not much in companies and not much in public sectors either, right? So the people that have they've done their education, they're kind of lost in the AI world. Here are a few questions that I'll try to answer. I mean, if this training would be beneficial, right, how can we do it? How can we train the essentials of AI? And should we do it at all, right? I mean, should we train the essentials or should we go into concepts instead? Can we do this in a few hours? I mean, how much time it takes to take somebody, let's say I go to the streets of Ljubljana, right? I stop a person, I say, I'm going to train you AI, I don't know. I mean, how much time would it take, right? Would it take an hour, a day, a week, a year? I mean, how complex this training should be, right? Can we focus on concepts rather than algorithmic details? I mean, how deep should we go? Can we train AI without the programming, right? Can we simply say that actually not everyone in this world will actually know how to program? In fact, minority of people know how to program, right? Can we train concepts of AI without computer science and programming? And can we indeed train anyone? So regardless of the background. In order to do this, I have to tell you a story, and so this happened about, I think, 6-7 years back. A good friend of mine came to my office, and she said, well, so her background was economy, and then she went to Brussels for a while, and then she worked in Google, and then she went to study digital humanities. And she said, well, I'm now in the middle of my study. I actually went there because I would like to apply machine learning to what I do, but I'm a bit lost because they've been training me how to program for now a good half a year, so learning Python and computing Fibonacci numbers. Here's the code, actually. You can barely see it, but doesn't really matter. And she said, well, I have this feeling that that the program I'm in didn't teach me any concepts of AI or machine learning that I thought it's going to be the essence of this study, the digital humanities, right? So I said, okay. In fact, I looked at the time then, and I said, well, my next meeting is in 15 minutes, right? So we have but let's try. Let's try to do something, right? Maybe in 15 minutes I can show you what machine learning can do, right? And I said, well, what are you interested in? And she said, fashion. Oof. And so I don't know, probably to you I don't look like I know something about fashion. So fashion is like, I know nothing about fashion, right? And I told her, well, you know, okay, but give me something, right? So I don't have any data on fashion, right? Give me any idea about what would you like to do? And she said, purses. And so do I look like a person that knows something about purses? Some people say yes, but definitely no. I have no, I mean, this is something that I'm really not interested in. So it was difficult, right? I'm having 50 minutes with a person that actually would like to explore the fashion and has through a case, you know, the purses, right? But then she guided me and she said, well, you know, if you go on the internet, right, and you type, I don't know, you look at the Dior purse, right? So this is, maybe I should go to the internet here. Okay, just for, I mean, this, so like purses, right? Purses, turns out, right, there's this whole word of purses, right? And you can, and she told me, well, you can type then the manufacturer or, I don't know, the designer, Dior, whoever, I mean, me not knowing anything, right? But these are the Dior purses, right? And there's something called Hermès purses, right? So there's, I don't know, probably a company or a design. So me knowing nothing, right? And these are how the purses look like here, Hermès, and there's Chanel, right? For Chanel, at least I know there was a lady called with this name, and she was a great designer. And I think she passed already, right? So there's this company, right? I said, okay, what would you like to know about the purses? And she said, well, maybe, you know, I would like to have a feeling whether these different companies are following some design principles, or I mean, how this changes maybe in time, or are there different design tracks that they follow, right? And then I said, okay, fine, right? So what we took, right? We took 3 different companies from that produce these purses, and we actually took the images of the purses and we just dragged them to the desktop, right? And what came out was like a simple data set, a purse data set, right? From Chanel, Dior, and Hermès, right? So I have these 3 folders now, each of them holding an image, I mean, set of images from the purse. Like this is a Chanel purse, for instance. Okay, so I don't know, it's a nice one. I have completely no idea here, right? So, okay, so I said, well, that's great, right? Because we already have a data set. And let's now do several things, right? In machine learning, I said, you first need to read the data. And I'm going to use a program where I import the images. I said, okay, read all the purses from my folder that we just created, and maybe just show her how this data set looks like. I said, the data set that we read looks like this, right? And she said, well, there's nothing, right? Because in every line, right, there's a purse. So there's a name of the category, basically the name of the folder where this image was put. The image name means nothing because it was just dragged from the web, right? And then there's the location of the image and some numbers in pixels of width and height of these images, right? So this is like completely useless for anything, right? And she said, well, maybe, right, let's see if we read these purses correctly. And here's the image viewer of the data set. This is way better, right? So this just presents the images. So every purse now has this label of the I probably shouldn't say designer, but of the company that designed and sells this purse, right? And I told her that based on the data I have, machine learning cannot do anything, right? Machine learning needs numbers to work with. AI needs actually something, right? Some numbers actually, and I need to change these images into numbers. And I told her that luckily, so this was 6-7 years back. Luckily, there has been just a branch of AI developed that actually produces these deep neural networks that can turn images into numbers, and the process is called embedding. So I'm going to embed these images and then just show you how this looks like. And then she said, well, that's great, right? Because now every purse, right, that I have in my data set, so all the 29 of them are described with numbers. I told her, of course, that I don't know what these numbers mean, and that this is a huge problem in AI, because if you use these sort of like big black boxes, there's not much explanation. You have to extract explanation later on. But she said, well, because we have the numbers, right, we can now perhaps compare the purses. So the idea is that if a profile, these numbers are actually vectors that represent the image of each purse. And if we have these vectors, we can measure the distances. So we can actually assess whether some purses are similar to each other. And that's exactly where we went. I said, okay, so we can measure the distances, but then it would be cool to find whether we have some groups. The idea would be that can we find which purses are similar to each other, simply based on these images, right? And then I showed her this. And I didn't actually, so remember, I just had 15 minutes, right? There was no time to explain anything. And I just gave her this image, and she said, great, right? So without explanation, she understood that these are actually groups, right? This is a group of Hermès purses. And there's a group of Chanel purses with, there's a sort of like an outlier. There's one Dior here, right? and she told me, well, it would be cool, right, if we can select, some of these groups, right, and we can actually see what are these purses represented. So every line here at the end is obviously a purse, right? So I'm going to close this one. So she was looking for basically explanation, and explainable AI is now, I don't know, the most interesting thing that happens that is happening in AI. She was already, basically this is a model, right? A model of my purse world, right? And these are the groups, and she was telling me, okay, try to explain these groups. And so the simplest explanation is going back to the images, and this is how it looks like. So I'm now constructing this sort of like explainer, right? So these are the Hermé purses, right? And maybe there's a group of, I don't know, there's a group of Dior purses, right? They all look the same, right? This is why they're in the same group, right? And these, they are, some of them are the same, just different color, right? So she said that's great, right? Because we already have an algorithm that actually can cluster. She didn't use this word. I think grouping was the name, but officially in machine learning, it's clustering that can cluster the images. And then she said, well, what about this pair, Dior and Chanel here, right? Oh, she said, that's interesting because this is actually almost like a copy of one and the other, right? So it's the same style, right? So it's produced by two companies that produce these purses. They both have a brooch here, and they have something like a chain here. And so she went into details that I cannot understand, right? But, and there's another one here, right? And that's already, so I think about 10 minutes has passed from our beginning of the discussion about machine learning and this purse analytics, right? And she's already finding out the patterns. And she's already finding out that there are certain styles that these companies adopted and actually designed purses that basically, to me, they look the same, right? So I can't say whether they copied, they probably didn't copy each other, but this was at the time the style of the purse, right? Then I also told her that actually there are other ways that I can analyze this data. For instance, I can build models that would predict who actually made the purse. And I told her this is called classification, and I'm going to test a particular classifier such that I'm going to take a set of purses, train a classification model on this set, and then test it on all the remaining purses. And I'm going to do it several times. I didn't tell her that this is called cross-validation. It's one of the procedures in machine learning, but I just told her that I'm going to use this classification and evaluation algorithms. Oh, here it gives me the arrow, so I should connect it here. So, and of course, what I'm going to do is I'm going to use the simplest classifier there is, which is logistic regression. And that's actually the machine learning algorithm that uses the code that I showed you about 10 minutes ago, right? So I'm using logistic regression. And it turns out that this classification performs fine. I didn't go into these numbers, but I said, well, when this AOC goes close to 1, that means that classification is actually accurate. But you can look this at confusion metrics, and I told her that if, so these are the actual designers and these are the predicted ones, and of course the things on diagonals means that the machine learning was right, and the things off diagonal means that was wrong, right? And of course she told me, oh, there are 2 Diors, so out of 10 Diors there were 2 that were mispredicted here, right? And they look like Chanel, right? Can you show me how this looks like? And of course I can do that here. I can use another image viewer, and that's, these are the 2 Diors, right? So the 2 with a brooch and a chain, and they are similar, to the algorithm, right? To Chanel's, so they were misclassified, right? And of course, she could make a story about this as well, why this is the case, why this was also noted in the clustering, and why it could be noted. I just showed her for the end another thing, which is a planar visualization, a map actually of all the, 29 purses, right? This is how they look like. And there's actually one, there's, I think, red and blue here that almost is on the same spot. I mean, most of them are sort of like spread, right? The green ones are here, the blue ones are here. There's some mixture here, right? So we can explore this, but maybe, so the one that overlap are these two, right? Well, that's interesting, right? Because I discovered this overlapping, right? Through classification, through clustering, and now also through visualization, right? And so here it stopped, right? This was 15 minutes. And then I had a meeting, and then she left, right? But what stayed with me, and I was so surprised at that time, right? This was 7 years back, right? It was actually the first time that somebody walks in and I can explain the things that are essential, that are the key components of machine learning. And machine learning is now the key component, or it's actually what we understand as AI, right? I could explain in 15 minutes. Maybe not explain, I could present, right? There was no deep explanation. I could actually go through the concepts, and the concepts were, I mean, this covered like data representation, distance estimation, clustering and cluster explanation, data embedding, classification, estimation of accuracy, and prediction, right? These are the main concepts in AI, right? So if people would understand what this means, they would understand how Google and Facebook work, and how everything that AI does works, right? These are the key concepts. You don't need to go beyond that. This covers probably 90% of the AI, just in 15 minutes, right? I'm not claiming that you can train anybody in AI in 15 minutes. I'm just claiming that it would be possible, given some more time, and escaping the details, and going practical, right? Trying to solve problems with people that actually are domain experts, and just showing them what you can do, right? Okay, maybe I'm gonna now back to the questions, right? How can we train the essentials of AI, right? And can we do this within hours, days, and weeks? And of course, I presented these questions because I probably have my own version of the answer, and there are many answers in the world right now, right? I'm just going to tell you what I think about it, right? So training the essentials of AI actually should happen, should be in practical classes, should be workshop-based, right? People actually should be presented a problem and work with it, right? And we try this, so later on, right, after these 15 minutes of my discussion with a friend and presentation, that was an eye-opener, right? We went and actually, we designed the workshops that were intended mostly at that time to a PhD students. We presented, so not PhD students of computer science, PhD students of medicine, of social sciences, of any branch, but not computer science. I don't know, in Houston, there was a class in, for instance, a class of medical students. In Pavia, there was a class of bioengineers. In Kolkata, there was a class of students in statistics and math. And we went around and we tested how much time do we need, and these classes actually lasted anywhere from 2 hours to maybe 10 hours in total, spread around across several days. So the answer is like, okay, how can we train, right? Okay, we should be practical, and we should train the concepts, and we can train this in only a few hours, right? So the question is, can we focus on concepts rather than algorithmic details and statistics? And the answer is yes. AI, interestingly, is not complicated at all. Machine learning has like some basic concepts that you can actually explain, I don't know, to anybody within an hour. So most of the concepts in machine learning are simple. The algorithms are not. So in order to design the algorithms, in order to, I don't know, improve machine learning, in order to understand what's happening within the algorithms, you probably need a PhD. in statistics, math, computer science combined, and then you will understand what's happening. You will be the designer. But this is not something that we need, right? Nobody of us designs nuclear reactor, right? While we understand what's happening there, right? Nobody of us designs internal combustion engine. It's too complicated, right? I mean, if you don't trust me, just open the hood of your car and look inside and figure out what's there, right? I have no idea anymore, right? But I know the principles. And what I'm claiming, right, we can, on the AI, we can focus on concepts rather than the algorithms and the details in statistics and math and computer science. We also then extended this idea, right? So we said, okay, we shouldn't just train PhD students because that would be I mean, of course, we claim that PhD students are very bright, they're eager to learn, right? But we should go across here, across to different audience, right? And so we went, for instance, and we designed the classes for public administration in Slovenia. We said public administration has to know what AI is. It's a very vital part of the society, right? Here in Slovenia, public administration is probably like 20% of all the employees in the country, right? So we designed the courses for them. We carry out about 10 different workshops. These were mainly the one-day workshops for public administration. We also went to different agencies and companies and designed workshops for them, right? And these were all targeted, so we needed to carefully decide what kind of data sets we would use, what kind of data we would analyze. But then the concepts were all the same, right? Where the classification, clustering, explanation, data visualization, and things like that, right? Just on the different data sets. So the workshops were designed for particular classes in terms of the content of the data, but the concepts in AI were all the same across everything that we've done. So there were also workshops, I don't know, this one, Girls Go Data Mining, so for, this was actually extremely well attended, about 100 students, not 100 students, 100 attendees, right? And we also went, and we experimented with that, but not much. We also went to high schools. So we went to high schools to actually check out whether can we do the training in AI in 1 hour. So they gave us only 1 hour, and we said, fine, right? And we went to the classes of, we usually didn't go to classes of computer science, but to some other classes. So this was our first experiment with this kind of audiences. The last two questions, can we train AI without any programming? I think I convinced you. So we can train the concepts of AI without any programming. And I think I should emphasize this. This is very important, right? Because the programming means that if you use the programming, you're going to be lost in programming with the audience that will not be computer scientists. Because you're going to introduce, so instead of teaching AI, you're going to teach programming and everybody's going to be lost. I think we should teach, especially in the primary and high schools, we should teach AI, the concepts of AI, without the programming. And it goes so much faster, you cover so much more ground. Of course, I mean, to developers, right? So those that actually going to build the AI systems, they have to know how to program. You have to combine programming with the AI. For everybody else, this is like 99% of the rest of the world, right? You should not go through programming to teach AI. And there's this hanging question, right? Can indeed everyone be trained in AI? Here you have to trust me. I think anybody can be trained in AI. Anybody can be taught about the concepts of AI, right? We've probably now done over 100 workshops across the world, right? I mean, through all the continents, met all kinds of people. And, I mean, everyone essentially enjoyed the classes and everybody left with some knowledge about the concepts of AI, to the point that actually they could go home, they could take some data set and then actually do something with it, right? Not to the point of just knowing the words, but to the point of doing, using the technology. Okay, so the question of my talk was, can and should everyone be taught about AI? I sort of skip should, because I think this conference is actually convinced that the AI should be taught in school, right? the answer for the can is yes, but about its use and concepts, and not about the inner workings of the algorithms. Okay? So it's not the case, right, that everybody should be taught what is the inside of the AI, but everybody should be taught about how to use it. The question that you didn't have in the title, and it's all important as well, should we and how should we introduce the training of AI in schools? And here I'm referring to elementary schools and high schools. So can we do that in schools as well, right? So I now showed you, there was just actually one photo from the school, and everything else was either, I don't know, companies, PhD students, like the grown-ups, right? But can we do that in schools, in elementary schools and in high schools? And the question is also, how can we do that, right? Here I should remind myself, right? Or maybe just a note to you as well, right? I remember my first class in school, actually, when I entered the elementary school, and there was this teacher, and we sat in these benches, and they gave me the fountain pen. And I couldn't use it, actually. I mean, I didn't know what to do with that, right? And so I was taught about usage of the fountain pen in the first class, and later on in the language class. There was nothing called technology class that would teach me about using the fountain pen. Or there was no fountain pen class, right? I use it in the language class. And so it happened with the calculator, right? There was no technical course about how to use the calculators. We learned how to use the calculators in the math class. And the same should be for the AI. AI in primary and secondary school should not be taught, so we should not taught about the use of AI in computer science classes. Or maybe I should say, just to be on the safe side, in computer science classes alone, right? I mean, I sincerely believe that we should expose the kids to AI in the classes of biology, chemistry, history, geography, language classes, music classes. So everywhere else, AI is a tool and should be taught as a tool. And we should not focus on technology alone, but on as AI as a tool. Okay, how to do that? So here are just a few examples before I finish and wrap up. This is an example which we can do perhaps in elementary school, right? We can take kids, I don't know, Ljubljana has a lot of woods around, and if you walk just 10 minutes, you're going to be, no, maybe just 5 minutes. Or even if you go through the city, there's lots of trees, right? So kids can take their phones and they can take images of the leaves, right? And then, so that would be a good biology class, right? They go, take out the photos, they name, they categorize the leaves, right? They name, like, is maple and black poplar or hazel. So these are all the stuff they actually found this Saturday when I was walking around Ljubljana, right? And then they can go back, right? And then you can teach kids how to make a prediction. So you would take another photo, you build a classifier on these leaves, and you would take some leaves for which you would not know exactly which trees are they coming from, and you can train them how to do that in an hour. Okay, how the software that actually takes the photo of the leaf and tells me what tree is that, how this works. I mean, perhaps not how this works, but that it's able to do that, right? And I mean, how can I use AI to do that? That's very interesting because it combines concepts from biology. I don't know, kids learn about the trees and the names of the trees. They learn how to use digital technologies like, I don't know, taking a photo and saving it on the laptop. And then they learn about how to use AI for the image recognition and classification. And they also will learn that there are all kinds of problems with noise, and that there are misclassifications, and the clustering doesn't work as intended, all kinds of things, right? And you can do it in 1 hour. And I believe you can do it in elementary school, maybe in the last grade. Or, for instance, right, you can go to a class of geography, you can take the data from the World Bank and actually see that there are huge differences. So if you take these economical and social indices, there are huge differences across the world, right? And you can take a group of the countries and ask, what are these differences? For instance, it turns out, right, I mean, I did some clustering yesterday, and here is how the world looks like, and you have the green area with developed countries and the red ones with something else, right? And there's Africa and there's everything else, right? So kids not only learn, I mean, by heart that there are differences, but they can actually explore this. They can find this themselves from the data, and the data is completely open, right? So this is World Bank data that just sits on the internet. And you can actually find clusters like, I don't know, maybe current politicians will be happy to find out that Slovenia indeed is by these indices clustered with the Czechia, Slovakia, Poland, Hungary, and countries like this. And you can ask them, okay, what is specific to this cluster? So you can ask questions why, right? And you can explore this maybe in a high school, trying to understand the specifics of the countries. Or you can go, I don't know, back to biology class and say, okay, here are the sequences of the spike proteins of some viruses. On the top is the virus that's bothering us, SARS-CoV-2, right? And there are some other viruses, and you can tell them that you can easily measure the distances between these sequences, and then maybe use the stuff that I already used today, the clustering, and then you show that SARS-CoV-2, the COVID virus, is actually very similar to the virus that was killing bats. Okay. So these are not only the ideas that I'm showing. Currently, we're partnering with Google. We would like to have this kind of courses in 20 elementary and high schools in Slovenia. We would like to design 10 different 2-hour workshops and execute them, so altogether 40 of them within the next year. We would then like to train the trainers, because I think this is essential, right? If you go with AI into schools, we are not the ones that are going to teach in schools. The teachers from biology and maybe together with the teachers from computer science and math, they're going to teach the kids, right? And they have to be trained. And we are looking for other means of long-term support of such an activity. So this is something that we are currently thinking about, but it's going to happen because of Google decided to give us some sponsorship of that. And you can join us too, right? There's the software that I've been using is completely free and open. It's developed by my group. It's called Orange Data Mining, and it's a great toolbox for training data science and machine learning. Already over 500 universities across the world use it in their courses, but not in primary and secondary school, right? And this is our next target. There are lecture notes available, and there's a set of YouTube videos with actually millions of views, which is quite interesting because of a geekish nature, right? I mean, you usually go to YouTube and you learn about the hairdressers and how to cook cevapcici, right? And this goes up, but geekish content like that is somehow overlooked. And this one is popular, right? Conclusion, AI is a tool, but the concepts behind the AI are simple. We should teach about its use and not about its inner workings. So this only for enlightened ones. Training of AI should be practical. We need to train the teachers first, and most of all, we need to ask them, the teachers in school, where to start and how to help them. I'd like to thank the ResetEDU team for allowing me to be on the stage today, especially Lenka Flander, who was very patient with me. I would like to thank my employer, University of Ljubljana, and 15 members of my lab, and our current sponsors. And if you'd like to explore more, here's a webpage of Orange, and you can write me in any time and have some other questions besides those that maybe you're going to have now. Thank you very much.
Thank you, Professor Zupan. So you grow Slovenian oranges, as we saw, and now we'll do some questions. So please remain on stage. I'm sure that our audience has questions. We have microphones, so we need some of you to raise your hands to ask questions. Yes, we have the gentleman here, and the microphone is coming.
Thank you, Mr. Zupan. You explained how to teach in artificial intelligence also for primary and secondary education pupils. In the beginning of your presentation, you also mentioned, let's say, to be aware of the challenges and risks. Is this also something which is part of these workshops to make the young people aware of the possibilities, but also the drawbacks?
So if you go, I don't know, if you take images of leaves, right, you will find out that there are lots of misclassifications, and the clustering can go wrong, right? And you can easily extend this to face recognition, and this is how you warn them that this technology is can sometimes miss, and it can be wrong, right? And sometimes often you wouldn't understand it, right? I would though answer. Europe lately puts a lot of focus about the ethical implications of AI, which is I think it's very important, right? But we should not forget, right, that we can only talk about the ethical implications once people know something about the technology. So I think both are important, right? We should not only focus on the ethics of AI, we should also educate people what AI can do and what are the concepts such that they can then understand why this is beneficial and also dangerous.
Okay, thank you. More questions for Professor Zupan? Yes, we have one hand.
You've mentioned that AI should be taught in classes other than computer science. My question is, how long and how expensive you think would be to teach, for example, arts teachers to teach something that's way out of their expertise and way out of their curriculum? Thank you.
This is something we should try, but I don't think this is hard. I think training the trainers would take one day. Convincing them that this is useful for them would take longer, right? So our approach here would be that we actually would work with teachers that are already enthusiastic about this idea, right? And we would design the courses that would be trimmed to a particular field or topic, and then sell this to the others, right? Selling means, in quotes, we should give it for free. And this wouldn't take too much time. We hope and believe, but there's going to be this experiment that will start in a couple of months, sponsored by Google, and going into, as I said, 20 schools, and we will try to design 10 different courses, and definitely not only in life sciences, but I think at least half of the courses should go into social sciences and arts, perhaps, like, I don't know, music as well, right?
Okay, 3 is the lucky number. Yes, we have the third question, and we'll have a fourth.
Thank you very much for this excellent presentation. I think there's a tension between the amount of data that we have available to us. It's been an explosion of data, and the temptation to explore it and mine it on the one hand, and the need for us to have theoretical models or frameworks within which to validate what we find. How do we balance this tension when we teach about AI?
Well, it's an interesting and difficult question. I think, my approach would be that we start small, right? We start with the little steps, and we start with the steps of understanding what the technologies can do and what are the basic concepts. Because these concepts you can take a small data set, like the PERS data set was just 29 PERSes, right? This was a very small data set, but you can do the same thing on a data set of 1 million images. And then you wouldn't start with these large data sets and with things that are, I don't know, at disposition at, I don't know, all these big companies, right? You would start with something small, something familiar, or something closer to what people do in daily life, and then you would then expand to bigger data sets, right? And I think it's great to have an overview of the field first before you dive into theory. And you can do that as well. You can do, so if you don't do programming, but you use kind of environments like Orange, which uses this visual analytic stuff, right? You can cover a lot of ground first, and then those students, also in elementary, I mean, also the kids in elementary school, or the high school, those that are really interested, right? They would go to computer science classes and they will say, oh, we need to learn more, right? But this is not for everyone, right? I often like to see the landscape first before I dive in. I think the rest of the people do the same.
Okay, we had another question by the gentleman in the white shirt. So there are 2 microphones coming, so you can choose.
Thank you for your enlightening presentation, and I would like to ask you, are there any restrictions or certain conditions for teachers to enrich their educational material they have at their disposal? Which conditions do you think teacher should follow for enrich their educational material?
Yeah, essential here. So if we want to introduce AI in schools, the essential component is we need to train the teachers. And we need to actually speak with them and see where is actually, I mean, AI is not a tool to be used everywhere, right? But so currently what we are doing, there's a colleague of mine that actually went quite deep with this, Janez Demšar, so my colleague from my lab, that actually now is scanning the programs of different courses in elementary and high school and trying to figure out where are the sweet spots for the AI. And then the next thing, of course, he talks with the teacher. So I would say there are no conditions, right? Other than, I mean, and I don't think that all the teachers will teach suddenly now, will introduce this. This will happen only in a few schools first, only with a few teachers first, right? But they're going to be sort of like the leaders. And if they succeed, right, the others will follow. I'm not saying that, I mean, there should not, I would be against something I would be against the politics saying, oh, now everyone should do that, and this is the way to do it. This is not how we should start. We should only help the teachers, those that really would like to enhance their courses with this new technology, and then we should see how this goes, right? And this should be I mean, okay, with small steps, but we should hurry up. We should not wait for 10 years. We should start now.